Hello, everyone, and thank you so much for joining us for this event. This is our first event at Hyperflex. Our event is titled Implementing App Search using Elasticsearch. As for some of you know, Hyperflex is a partner of Elastic. We are an MSP partner, service delivery partner, and a reseller. Basically, everything you need with Elastic. We do consulting with Elastic. We are here to support you with anything related to your Elastic environment, security, search, observability, GenAI, anything related to your Elastic environment. We are an expert and we have the right folks, certified engineers to support you. So for today, implementing app search using Elasticsearch, we have our host, Vishal Rathod. He's our CTO, search CTO. And our guest, Aman Saxena from IBM. Aman is a software developer and he has multiple articles on Medium about Elastic and other subjects. So today we're gonna co-host an event that we are really excited and we have been preparing for a while to present. So the event will be about a use case that they had the opportunity to work on and to work on together for us today. So thank you so much all for joining for this event. Feel free to leave us any comments. And yeah, I think we can kick off and start. Vishal, you can start. Thank you so much, everyone. And yeah, feel free to leave me any questions on the comments and we will manage that. Thank you so much.
I want to start with two very important reports. One is that Google surveyed that 53%, that is more than half of your potential customers, drop if they are not finding the right data in right time. 53%, that's a huge number. And then we also know that there is increasingly a drop in the attention spans of humans with so much social media and quick dopamine releases. We have the attention period dropping, and hence to sustain our business, our search is the number one pillar. We want to give them quick and intelligent search. So what does quick and intelligent search actually mean? So we define a great search experience onto four pillars, that is fuzzy search, semantic search, type ahead, and personalized boosting. Let's understand each of one of these in their business impacts. So fuzzy search refers to when the user is not able to type or is not typing the correct spelling, but my system should be intelligent enough to assess what the users may be trying to say. In this example here, you can see this is the demo that we have built for you, and Aman will be showcasing it you how it was built and the workarounds. But to give you overview, here when I'm searching for adventure, you can see I have mistyped the information. Still, the system is intelligent enough to understand that I'm looking for adventures, and it gives me results based on my adventure. Comparing it with Amazon, which is like the pinnacle of search, we can say onto the global scale. And how here you can see I'm not typing the shoes spelling correctly. Still, it is giving me these suggestions for shoes. Basically, with Elastic and App Search, we want to level play the field based on the top retailers and e-commerce to SMBs. Next comes the semantic search. So here, semantic search refers to synonym search, you can say. For example, somebody is searching for shoes. I should also be able to show them relevant search results on sneakers or boots. Amazon, coming to the live example here, when I'm searching for pen, it is also showing me for pencil and pen drive. So it are like semantic searches are being implemented. All these synonyms are being clubbed into one. And then the third pillar is type ahead. My users should be do not have to put should not have to put a lot of efforts into finding the right product. Here, when I'm saying Hollywood, I'm trying to search Hollywood. I've just written half of the word. Still, I'm getting all the relevant searches. I'm searching, getting a result for Hollow Man, one of the movies, and then Hollywood. Same, you can see on the Amazon. Based on my search history, they are suggesting me a couple of searches so that I don't have to put on a lot of efforts on finalizing and filtering my searches. And then finally, and the most important one, I would say, is personalized boosting. With so much of the data growing exponentially, it is very important to pinpoint the search results in the minimum with minimum efforts. Here, I'll show you two examples based on the demo that we have built. First, on the same platform, I'm searching the same keyword, that is Wayne Johnson, one of my favorite actors. We have one of the users who has personalized and history into watching action-based movies. So the first result he's getting upon searching Wayne is Doom, which is an action-based adventure movie. And then for another per user who may be more into comedy movies, he's getting Get Smart, which is a comedy-based action thriller movie. So this is the power of personalized boosting. And here's a funny example. When I was searching shoes on my Amazon, instead of showing me shoes for men, it is showing me shoes for women. And then I realized I have a younger sister who is always trying to bug me. Why save money when I can just use my brother's credit card? So she's almost always ordering from my account. So even though by default it should show me the first result should be shoes for men, it shows me shoes for women, all thanks to my younger sister. So that's that being the theoretical about it. Let's dive onto the technical implementation and see how are these searches being implemented on Elasticsearch, and how can we bring all of this to your businesses directly to your doorstep. I'll let my friend Aman start the demo now.
Okay, so I start with the engine which we have created in app search feature of Elastic. We have named it Movie Refined, where we have 4,000 documents. So I show you the schema first. So this is the schema, the ID, overview, original language, director, title, the major part of a movie, which should have cast, the release date, genre it is. So first we talk about the fuzziness of the like whatever we are searching. So app search has given a feature of search UI where user can search what the result they will get. So I will first introduce you with the UI. So this is title field, which is going to title of the movie. Filter, we can set filters. So I'm going to set filters as language and genres. So and we can sort it by the need, like popularity, and I think popularity is enough. Then just generate it. So this is the result which it has provided us. These are the filters on this side, which have a language and genre and sort by feature of popularity. So we can do popularity like this in ascending order, and this is for descending. And this is related to the relevance. Here we can select English and we can get result according to it here. And we can search movies. So what fuzziness is, let's say I want to search for a adventure. So this is the spelling which I have put. So this is similar in, so it's able to find like adventure or words which are related to adventure. So the misspelling. So it's going to, that's what Elastic does. It keep finding and creating words which are similar to it. If and To set up the fuzziness, what we can do is we can go to the relevance tuning inside the engine, and we can set it here in recall and precision. Recall means like right now recall is set to 2, which means all we need to do is like if it matches half of the term, it will give us the result. If we go for the exact precision, that it will mean it is an exact match and we won't find anything if we put a wrong spelling. Let's do it again. Now we are getting no result because of the fuzziness. So that's one side. Another, now I explain you about the another feature, synonym, which is semantic. Let me set it back to 2. Yes, synonym. So what synonyms are, let's say we want to watch a movie which is related to battle, but another term for battle is war. So now I want to have movies which when I find battle, and it can have war as a keyword. So I do the same thing. Genres. Okay, now battle. So it has battle as a keyword. Every movie has a battle as a keyword, either in title or in some of the note which we are doing text search. Let's go to page 5. Here also we can see battle. So this we have able to find battling also. And okay, now we got a movie called Journey from the Fall, which does not have battle as a keyword, but it has war. That's why we're able to connect it to the battle. Now we are getting a result for this. That's how we work, and that's how we can add more keywords to it. That's how it with synonyms will work. We can add more values if we have some other value for it. Uh, Now the third part is curation. Yeah, so what curation does is we want to set up a movie. Let's say it's a personalized feed for someone. I like comedy. So if I set up a comedy, what it does is whenever we search for comedy, it will give us a result like this. If we go check for it, we have created one curation for that. Crying with laughter, South Park bigger, longer, and uncut. If we go here, so this is the result which it gave us for the when I search for comedy. Now what I can do is I can add the result manually. I can curate new data. Like I want Zoolander first. So here I can add it, and Zoolander 2 also I will add it. This will do what? This will once I will find it. If I want to search for comedy, now it will give me a personalized feed which will have Zoolander first, then Zoolander second, then the other movies. So that's how curator work. This and there's one more feature in curation, that is to remove movies, hide results. So like I do not want to watch this movie. I do not want want this movie as a recommendation. So I can add this the same way. Now let's go. This is the first result, and comedy, Zoolander 2. Now the third movie which we have removed, we have logged is has gone. That's a very personalized feed for us. Now the third, which is I think is very relevant to it, is boosting. How we want to boost the node and from where we want to get the results. So let's say whenever a user search, first thing I want to do is let him search from the title. Then I want him to search from other nodes. Like let's say I want him to search from titles and genre. Okay, maybe 4.3 overview, cast. Now I want to find adventure. Oh wait, I haven't done this for title. Okay, so because we have given title as a highest boosting, so first result we got is the one which matched the title. Once the title are done, then we get other result which are related to genres and overview because we have put it there. But let's say if I want to put genre as a first criteria and want to boost that more than any other field. Okay, so the result has changed. Now, first thing we are getting is from genre. So by the boosting we can change the result. And the best way which I have used boosting is for the popularity. Let's say if a movie is in some other year but it's more popular, then we can boost it and change the result according to it. That's all from my side for the presentation. Back to you, Vishal.
So let us discuss the practical implementation of whatever we just saw onto how it is actually helping the businesses. So we have, I'll be talking about one of the case studies that we have recently implemented for an e-commerce giant. They are primarily into offline business, but they recently started their e-commerce arm. So this is a hardware equipment firm doing $100 million in annual revenue. And so I'll talk about their whole e-commerce journey. So when they started, so we had this couple of KPIs that we wanted to implement. I'll talk about each one of them. So a couple of KPIs that I was talking. The first KPI was, so we have this user journey. People land on the homepage and then they view the products. Right. And then, so that is the search journey. We should be able to give the relevant results to the users. So this was one of the KPIs, and we were able to implement it. Almost 28% of our users were directly able to view a product without actually searching for anything based on the personalized history. And then the second KPI was how much the user actually have to type in. So when we launched the product, people were earlier searching for typing on average of 8 characters before they land on a product. And but then again, thanks to the personalization boosting that we implemented, we were able to show the relevant results to just in 4 characters. So that was a big win. For search latency, we have this KPIs on what are the users actually searching and how much time is it taking them to go to the average product. So that is where we have the search analytics features directly embedded into the app search. And we can see how many queries are being run, what are the total amount of clicks, and what is the average latency. And then finally, if users are dropping, if they are not finding the accurate product. So here we have the stop queries with no clicks analytics implemented into app search. And then we were looking into what are the queries that people are not finding anything for. And that is where we would try to implement better inventory management and show them boosting on the appropriate results. This is the brief architecture. So we have a couple of sources coming in data from. So we have marketing data, we have surveying data, and then the actual source of truth. All of that was being ingested into Elasticsearch, and then app search engines were running on them, suggesting all the relevancy engines. As and more the users were interacting with our platform, we have this personalized positive feedback loop where once the users logs in, we start collecting more and more history about that. And then all those personalization and cookies would go into the meta engines, which in fact would feed this data into our primary engines. Based on this, we were able to increase our relevancy by 10 to 15% with each visit of the user. And how do we measure the relevancy? What are the people searching, and what are they clicking on actual results? That's it about so far. Let's touch base on the next future upgrades. A lot of people had this question. I guess most of the questions that we saw today were on ML and further analytics. Let's see how many people would want to talk about vector search. You can type in within the chat. We can do, if we see enough interest, we can do another dedicated webinar on vector search using Elastic. In the meantime, I'll just talk that with vector search, you basically can do a lot of searching on unstructured data, that is image search, audio search. And what it does is it would create a vector of anything that you're putting it in and then generate a search around it. One of the features that has been primarily working in the new Gen AI wave that we see. So if we see, we'll probably plan another event dedicatedly talking about vector search capabilities and its implementation. And there we can cover the NLP questions that we saw, and then other analytics integration that we saw in the questions today.
Well, thank you, everyone. Thank you, Vishal. Thank you, Aman, for being our guest for this talk about Elasticsearch. And if you have more questions, feel free to contact me directly. We are here to support you. Thank you, everyone. And yeah, wishing you a great day and see you soon for our next events. Thank you, everyone.
If somebody else wants to do webinar with you, Yasmin, how do they reach out?
Please contact me directly through LinkedIn. That was something that I was supposed to ask. If you are interested, I completely forgot. But yeah, absolutely. If you are interested to co-host an event with us, either in person if you are in New York or in Chicago, or over Zoom, please contact me directly on LinkedIn or by email. I can also share my email here. And also, you can also contact us directly through our website on the contact page. We will be really happy to have new folks co-hosting event with us. And thank you again, Aman, for being our guest today. Thank you so much.
Thank you. Yeah, thank you. This was very, very exciting. And big fan of your blog, whatever you write for Elastic community. So thank you for sharing.
Thank you. Thank you so much.
Okay.
Thank you, everyone.